All right, IM3 classes. Today we are going to be solving exponential equations. So we're actually going to be using those logs that we've been working with the last few lessons to solve an exponential equation. So let's go ahead and look at our first example. 3 to the v power is equal to 72. So on the very first lesson, or if v was a whole number, this would be easy to just guess and check. You put it in a calculator, guess and check. But v is not going to be a whole number on this one. 72 doesn't come out to be a power of 3. So what we need to do is use a log to solve the equation. First thing I'm going to do, before the first step, I'm going to put in a little line of separation so we can see both sides. But the first thing you do is you're going to take the log of both sides. So it's going to be the log of 3v is equal to the log of 72. All right. And then what we learned last time, one of those properties of logs is when there's an exponent, you can move it out into the front of the log. So we get v times the log of 3 is equal to the log of 72. And then from here, what we can do to finish solving for v is now just divide both sides by the log of 3. So log of 3 divided by log of 3 cancels out. We just have v is equal to the log of 72 divided by the log of 3. Let me switch over to a calculator. So put this into a calculator. Log of 72 divided by the log of 3 is equal to 3.892, rounded up to 893, 3.893. And I need to switch back over to, there we go. So this is 893, I think it was. Yeah, 893. So to solve an equation where you have an exponent here, the variable in the exponent, what you do is you use a log to get that variable out of the exponent. Then you can use the properties of log so to bring it down in front, and now you just divide to solve. All right. So let's look at an example where there's going to be more than one step after the end. So we have 4 to the n minus 3 is equal to 16. This one actually does come out to a whole number. But let's work this out. So first thing I'm going to do is take the log of both sides. So it's going to be the log of 4 to the n minus 3. Write that better. Oh, geez. There we go. Is equal to the log of 16. All right. Now I can move the exponent, the whole thing, that whole exponent of n minus 3 out in front, bring it down using the product or the power property of logs, move it in front. So it's going to be n minus 3 times the log of 4 is equal to the log of 16. All right. Now I can solve from here. I'm going to divide both sides. Actually, I should use some parentheses just to clean this stuff up a little bit. I can divide both sides by the log of 4. And so these cancel out. Log is 16 divided by log of 4. You can put that in a calculator. That actually just comes out to 2. So you get n minus 3 is equal to 2, and then finish solving for n. So I'm bringing down that n minus 3, finish solving for n. I add 3 to both sides. I get n is equal to 5. All right, again, so the tricky part, getting the n minus 3 out of the exponent, you take the log of both sides, so you can use that property of logs to move that exponent out in front. Right, so let's look at another example. So here we go. 16 to the negative 2 is equal to 64. So again, the first step, what I'm going to do is take the log of both sides. So it's going to be the log of 16 minus 2x is equal to the log of 64. And then from there, I can use the property of logs to move this negative 2x out front. So it'd be negative 2x times the log of 16 is equal to the log of 64. To solve from here, I can divide both sides by the log of 16. And then use a calculator for that one. Log of 64 divided by log of 16. So that comes out to 1.5 or 3/2 if you prefer. We'll just do decimals. So negative, so this cancels out. You're left with just the negative 2x is equal to 1.5. And then the last step is I need to divide both sides by negative 2. So you get x is equal to negative 0.75. All right. One more where it comes out to nice, neat, not necessarily whole numbers. This won't come out to a whole number. A little bit neater than some of them. First step, I'm going to take the log of both sides. So it's the log of 6, the 2n minus 1, to the log of 36. So now I can use the property of logs to move that 2n minus 1 out front. And then I'm left with log of 6 here, and then log of 36. Divide both sides by the log of 6. So this will cancel out, and you get 2n minus 1 is equal to log of 36 divided by log of 6. That comes out to 2. So now it's just a simple two-step equations. Add 1 to both sides, you get 2n is equal to 3. Divide both sides by 2, you get n is equal to 3/2 or 1.5, whatever you prefer. There we go. And so let's look at what we do when you have more than just, well, we're going to skip that one. That's pretty similar. We're going to more than just a base and exponent on the one side. So you do get these problems where there's kind of a lot to work through here. So I can't take the log of both sides. I mean, I could take the log of both sides at this point, but that's going to end up being more work. So what I want to do is just work down to where I have just the 17 to the power. So I'm going to divide both sides by -4. All right, I can't multiply these two because this 17 has this power. All right, this -4 doesn't have a power, so we're not multiplying can't multiply those. I can divide it out. 84, negative 84 divided by negative 4 is 21. And then I'm just left with 17 to the negative 7b over here. All right. Now, since I'm down to just the base with the exponent on this side, this is where I can take the log of both sides. So it's the log of 17, the negative 7b equal to the log of 21. Now I can use the property of logs to move the exponent out in front and multiply, make it a coefficient. So it's negative 7b times the log of 17 is equal to the log of 21. And this one's going to be messy. This is going to be big long decimal. So I'm going to divide both sides by the log of 17. So this cancel out. I will get negative 7b is equal to, I need a calculator for that one because that's a mess. So 21, 17. So log of 21 divided by log of 17. That comes out to 1.07. I'm going to round that up to 5, 1.075. So 1.075, and then I need to divide by negative 7. So this will cancel out. I get B. B is equal to 1.075 divided by 7. So 1.075 divided by can't remember. Yeah, negative 7. Negative 0.15, round that up to 4. Negative 0.154. Oh no. Sorry, thought the battery died on that. Negative 0.154. And that is it on that one. All right, one more problem. Long problem. This is as long as these problems are going to get. It's a good thing because this one, a lot to this one problem. So first thing I need to do is get this down to just the base with its exponent. Then I can take the log of both sides to get the variable out of the exponent, put it in a coefficient, and then solve everything from there. So my first step here, I have 5 times 4 to the 4 minus 5n minus 8. I'm going to add 8 to both sides. And so I get minus 8 plus 8 cancels out. It's 5 times 4 to the 4 minus 5n is equal to 12.7 plus 8 is 20.7. Now I need to divide both sides by 5. So this cancels out over here. I'm not going to keep switching back and forth. I'm just going to use a calculator here. 20.7 divided by 5 comes out to 4.14. So I get the 4 to the 4 minus 5n is equal to 4.14. Now I can take the log of both sides. So log of 4 to the 4 minus 5n is equal to the log of 4.14. Now I can use the property of logs to get that exponent out of the, to make that exponent coefficient. So it's 4 minus 5n times the log of 4. is equal to the log of 4.14. Space, I'm going to bring this down. Now I can divide both sides by the log of 4 to start working on getting the n by itself. So divide by log of 4, divide by log of 4. This will cancel out. You get 4 minus 5n is equal to log of 4.14 divided by log of 4. So let me put that in a calculator. Log of 4.14 divided by log of 4. That comes out to 1.025 rounded. So 1.025. Subtract 4 from both sides to eliminate that 4. Keep in mind, so that minus stays with the 5. So that's a negative 5n is equal to 1.025 minus 4. You get negative 2.97. 975, excuse me. And then last step, divide both sides by negative 5. You get n is equal to 0.595. And that is it on that one. So next time we're going to go backwards. We're going to be given log equations, logarithmic equations, and we're going to use exponentials to solve logs. Fun times. See you then.